Hi, I'm Ryan, and today I'm going to show you how to build version 4 of the Arduino compatible mini claw machine. Before we go into the assembly, I want to talk about some background and the journey that I took from building this claw machine and all the iterations before it. You can see version 1 was, I had no idea what this is going to turn out to be. I bought really big aluminum extrusion and I just hashed it together. This quickly evolved into a lot of things that I wanted to change, and version 2 started to take form. Bigger footprint, smaller frame, and it started to look more and more like a claw machine, but also it eventually devolved into something really complex. I settled on version 3, which is, I'll coin, the most robust iteration of this design. This design referring to the aluminum extrusion. And I'm really happy with this one. It's great. If you dive down deep into this thing, there are so many parts. It's so complicated. And when it came down to, I wanted to offer this as a kit, this kit that I had to put together, source all these parts and put them in plastic bags, it just became too much work. Even the bill of materials was easily over 500 pieces and parts once you start counting all the nitty electronics. And this wasn't doable. It wasn't viable for selling a kit. So I started from scratch almost for version 4. And in order to make this work, I had to rethink the gantry all over. I found these linear rods with bearing blocks and decided to just buy those, build a design around that. Assembly starts by gluing together the control box, or where the user's going to use the controls. The goal for this design was to eliminate all aluminum extrusion and obviously cut the bill of materials and overall parts cost by at least half. So doing the body with wood is what you see here. I installed the bars that support the prize floor, and then the dividers for the prize chute as well. Glued together with brackets, then you can take the brackets off later, and the bottom parts of the brackets, that line where things go. And I'm just marking the holes, and then I do the divider for the top. The control box, once it's dry, gets inserted and it's held together with the number 6 bolts and screws. The control panel stack just glues together, just like all my arcades before, and you can glue this together prior and then install the controls. The gantry, though it's much simpler than the version 3 gantry, you still need a 3D printer to print some parts. So we're looking at a couple brackets for the X and Y transition, as well as the belt clips that hold the belt for the X position. I did have to tap all the way through on one of these bearing blocks so I could get the belt clip assembly underneath. But that was like a $2 part to buy a M4 tap online. So more of the same bearing blocks get mounted, this time just 90 degrees from the first orientation. So this gives you your X and then the Y, and makes up the carriage of this claw machine. So the brackets go in the pre-cut holes. And I made cutouts on the back of the claw machine because these rails are 300 millimeters long, and the frame of the claw machine is 15 by 15 inches. And I wanted to avoid having to cut with a hacksaw or a cold saw the bearing rails. This part is the idler pulleys that loop the Y pulley belt around the claw machine. And these are M5 really tiny bearings with a larger diameter M5 washer on the end to keep the belt on track and from slipping off. We'll pull the rails out just a little and drop the gantry in. And then we can put the back of the claw frame on. And you can see those cutouts right there. These bearing blocks aren't amazing. I was just showing you every time I put the rails in, a bearing falls out, but that's fine. Here's the X carriage plate that mounts the Z motor and the X motor. Only using 2 bolts, that's all that's needed for this assembly. Then another bolt with spacers puts these two together. Now we'll mount the idler pulleys for the X belt. These are just flange bearings, and then we'll mount the stepper motor in the top. This is the X gantry motor. You can see gantry's pretty much done, and everything's sliding. Once you slide it back and forth, you can tighten down on all the bolts. Now we'll put the belt clips in, and they just clip onto the ends of the rails. And after lining everything up, that's the gantry. With the gantry mostly done, we're going to move on to the inside fixings of the claw machine. This is another idler pulley for the Y belt. Since it loops from the top all the way to the bottom, we have 4 points of contact, 3 idler pulleys, and the Y stepper pulley, which is shown right here. So it mounts onto the right side of the claw machine if you're facing the claw machine, and there's some large 3D printed spacers to offset it. We're going to focus on the electronics next, and the first thing to note is where we're going to lay them out. So we have to mark the off-limits parts with red, like where the quarters are, the prize chute, the one stepper motor, and all the wirings for the operator panel. And the blue indicates the portions of the electronics and where they're going to go relative to the front of the claw machine. I'm just marking where the coins and the Y stepper motor are, the control panel, since a lot of wires are going to poke out of there. And I've just drawn that in pencil. And this is where you're going to lay out where everything goes, mark the hole mounts of your set electronics, drill those holes, and mount with the appropriate screws. This is a layout I picked. It seems to fit everything, and it also gives enough space for routing wires between electronics and so on and so. Here's all the electronics already wired. I don't have the patience, and you probably don't want to watch a 30-minute video or a 15-minute video of me wiring everything. But I did make a schematic, and the schematic is best to reference how I've wired everything. Step by step, we wire the 4x20 LCD first. Then we'll wire one TIP 120 Darlington transistor. Connect that to our stepper motor. Here I'm showing 2 Y stepper motors for version 3. It's optional. Then we repeat that step for the X stepper motor and then the Z stepper motor. So we have 16, or in this case, only 12 TIP 120s. We're going to mount the user controls, which is what you see all the way on the far left. The analog pot for the claw, some indicator LEDs, the power switch that cuts off power to the servo motor, and then some more operator controls, the interior lighting, and finally the limit switches that connect to the Arduino Mega. That's what everything looks like. It is a rat's nest because that's just how I wire. I'll zip tie everything when I feel like it. So it's best to do all the electronics, wire everything with the base open, and then I've made big enough cutouts for everything that you can thread things through, because you do not want to wire everything in a tiny cramped box. It sucks. Here we're mounting the start button to the front, connecting to it, and you can see I've already done the user controls with the joystick, the 2 arcade buttons, and the potentiometer. It connects just like every arcade I've built. So go watch those videos if you're not totally sure what's going on. These are the LED 12-volt light strips that illuminate the body. It's optional, but it totally makes a difference when all that candy just glows with nice, shiny blue tinted LED light. I made some long wood strips to mount these lights to, and just 3D printed some 90-degree brackets. So this is its own sub-assembly, and it can be inserted when it's complete into the claw machine. The operator control panel, which is just what claw mode you're on, if free play is enabled, enabling test mode, and just power switch. That gets all wired separate, and you can see it's the cutouts are large enough that you can just slip this thing through when it's all done. So I wanted to avoid wiring inside a tiny box, because I did that with version 3, and it's no fun. So we'll put the yogurt lid, or the yogurt cup that catches the quarters, and we'll start connecting some things and threading some wires through to get them out of the way, and start planning where these wires are going to mount. Also keep in mind good to start planning some cable ties and some upkeep as we progress further. Next, it is time to thread the belt through the 3 idler points and the stepper motor. You might have to remove that large diameter washer to get it through in some locations because it's such a tight bend radius. You're not going to get the belt to bend through when you fish it. Now we're going through the inside bottom, and you can see the Y stepper motor has to go through there, and that's what those 3D printed spacers are for. Make sure there are no other cables in the way, and it threads to the top. And we're going to mount it to the bottom of the linear bearing block. And again, I said before, I had to use a thread tap to tap from the bottom all the way to the top, so threads come through the bottom of this linear bearing block. And I'm using those threads to insert screws to clip the belt onto it. Next, we'll mount the Y limit switch. This is the front of the claw, so when the claw goes home, it comes to the front. And then the same thing for the X limit switch, goes all the way to the left to drop a prize at game over or time out. The LCD is a HD 44780, just your standard run-of-the-mill LCD, 4x20 characters. There's no mounting holes for this because some of the PCBs tend to differ. So you'll have to insert it backwards, mark the hole, and drill mounts for this. The next thing is how to insert a quarter. I wanted to put a commercial quarter acceptor or coin mech on this thing, but the coin mechs are way too big for this size of machine. I found these low force limit switches, which are made for mechanical coin acceptors, and I had to 3D print this quarter chute that would funnel the quarter from the front when it's inserted downward and force it to go over this switch to activate a coin insert. Yeah, you could probably put a nickel in or a Canadian quarter and it'll still trigger. But when it comes to tamper proof, you could just unscrew the screws of the front and rip this thing apart. So, there's only so much you can do. You can see when I'm putting the quarter in, the yogurt cup mount is what's going to capture it. So this is going to be your bucket full of quarters, hopefully at the end of the day. And when you insert the prize floor with the quarter chute mounted to it, everything should line up, and this will funnel the quarters from the outside through the inside of the claw into the bottom of the operator's area where all the electronics are stored. And you can also mount the prize divider to the prize floor too. The claw for this is the first claw I made. I was just copying what I saw online, then I revised it. This one was a little bit better, but it wasn't quite balanced. I really wanted a 3-finger claw. Here's one attempt I made, then another attempt I made, and I still wasn't really happy with these. In the end, I wanted an analog controlled claw. So this was the final version I settled on, and it's really simple. It's just a servo motor, 180 degree, with 2 geared claws on it. And the nice thing about this is it stands up on its own, so when the claw drops, like in a traditional mode, it'll stay standing. Then the Z pulley that pulls the claw up, I actually made this on a lathe with 1.5-inch stock, and then drilled some holes, tapped them with an M5 diameter shaft, and this just fastens onto our stepper motor. We're going to connect all our power to the motors, and you can see when we pull the claw up, it's supposed to hit the limit switch, but it doesn't quite. It goes all over the place. So we need this Z stop bracket, which is pretty simple. It's just got some weird alignment with the holes I've already cut. Then fasten this to the X gantry, and you can see when we pull the claw up, it stops, and it's forcing the limit switch to get triggered, and the claw can't go anywhere else. The other thing you might have to do is flip the front-facing LED light panel, just so there's clearance when the gantry runs into the front. Last is, well, almost last, is some aesthetics. This is the cap that I made, just with a name, some fluorescent colored acrylic behind it. This also kind of stiffens up the top. Since there's no hard corner brackets in the top, the machine can rack itself or rack back and forward. So fastening the Fastening the claw machine to another stiff square bracket kind of reinforces the gantry to stay on track and not have it rack side to side. Here's some beauty shots because we're all done. So you can plug in power, and if you wire everything correctly, the claw will go to its home positions in the Z, Y, and X, and you can start playing a game. I did also add a test mode to this claw, so added some code, and this is good for troubleshooting and verifying all the inputs you've wired correctly. And if the inputs are wired correctly and you've connected all the motors correctly, you can just manually override this and test how the gantry moves, the limits of motion, and so on and so forth. I also made a claw that's telling you the degrees and position that the claw is in. So I have this set to not open more than 120 degrees and close at 179. And also I can trigger the limit in the X, the Y limit switch, just to verify their functioning. You could consider assembly finished at this point, but there's a couple finishing touches to this machine that really make lasting effects. We're going to change the prize floor barrier to clear, and I'm also going to add all the clear windows to all four sides of the machine. This front piece of trim also brings the user's or player's eyes to the instruction screen and the coin slot. During normal play, this is going to happen. The claw machine, or the claw, will get stuck on the servo cord. This wire loop will catch the slack and keep the cord from getting caught underneath the claw. I'm also going to add this other piece of trim inside the claw just to cover up the exposed PCB of the LCD screen. Add some candy. More candy. And you call this mixed candy. I see two M&Ms touching. It's time to win some candy! First, we'll turn on the machine. You have to remember what side the switch is on. I moved it, which was super smart. When the claw power's on, it's gonna go to the home position in the XYZ, and that's what it's doing right here. Super. Insert your quarter. US preferred. If you're a continuity checker, I would turn this video off because I spliced in a bunch of shots and it's all weird. This is the full control mode you're seeing right here, and this bout of overconfidence will soon be shattered. But the full control gives you 50 seconds to grab as much candy as you can, bring it back to the prize chute, and repeat over and over. It becomes a game of skill, and it makes it really fun. It gives some... It's very rewarding when you're winning at something, and that was the whole build behind this claw machine. You can see the time limits displayed with numbers and a graphic bar, you know, real fancy. Just doing real well right now. This claw machine is got its nuances, just like real ones. You can see the pure ponage right now. Some more Snickers. Overhead shot. Love the overhead shots. And when the time expires, so when 50 seconds is reached, the lights will blink, the claw will close, so if it's grabbing something, it will take that back to home and go back to 0 position and open the claw. Now, what claw would be complete without a traditional mode? So I call this luck mode. So this is exactly what you'd see in, you know, movie theaters, arcades, where you have a limited amount of time, like 20 seconds. You only get to move the claw in the X and Y direction, and you hit a button, it drops and grabs wherever it is. You can see this took me a few tries, but finally got it on the last one. Well, last one being relative, because there were a couple takes. Got it. Alright, well that is pretty much everything I wanted to talk about. If you have any questions regarding this machine, check the website. If you want even more details about assembly, schematics, electronics, check the website. My website is RetroBuiltGames.com. And in conclusion, this claw machine has been about a 2-year project. The first 3 iterations of the machine There's easily 1,000 hours worth of design work and troubleshooting. A lot of that design work came from mechanics, and a tiny percentage was the software, just trying to get the feel of working with Arduino and getting the right behaviors, and then enhancing the code, optimizing the code. To assemble this machine, which I'm calling version 4, there's about 12 hours worth of work here, and a lot of that comes from 3D printing one part at a time. And depending on how good a job you want to do as far as cleanliness with the wiring work, that 12 hours can drop down to maybe 6 if you're in a really good mood and just power through it. If you want to know when kits will be ready, I don't have a date yet. It's going to be when they're ready. But again, check the website because I'm always posting information. And my goal is to make this a do-it-yourself kit because everyone needs some practice on one of these machines. So thank you guys for watching. Take care. Have a good one. Oh, I hate this machine. I'm gonna fix that one later. I know how to fix that.